Hey, what's going on, guys? This is Danny Tech back with another video. Today what we are going to be going over is ether channels. So on the CCNA exam topics, what we can see here is that 2.4, basically the topic that is that Cisco wants you to cover is basically to configure and verify layer 2 and 3 ether channels, specifically LACP ether channels. So now there are two separate ether channels that you're able to use when networking. One is proprietary to Cisco. Now when I say proprietary, that means that you're only able to use that between Cisco devices. So if you try to configure that protocol between, let's say, a Cisco device and an Aruba device, which is HP, Hewlett Packard, that won't create an ether channel basically. So that is something that you need to keep in mind. When you're out on the field, you're not always going to have the same vendors, as you're using networking devices. So that is something that you need to keep in mind when you're configuring these protocols. So let's go ahead and get into the configuration. But before we do that, I want to just talk about a little bit on why we're using an ether channel. So when we are connecting switches and we have redundant links on these switches, so let's see. Okay, that's fine. I don't want to connect it. So when we have redundant links on switches, right now I only have one link. So right now it's waiting. It should show green now in a couple seconds. So yeah, see how it's showing green? That means traffic is able to pass within these links. Now say we connect more links. Let's say we connect 4. Now what happens is that to prevent a broadcast storm or a layer 2 loop, what these switches are going to do, they're going to go through what's called the spanning tree protocol. So this basically is a protocol that was implemented to avoid broadcast storms or loops. Now when it goes through that protocol or through that process, it'll basically disable some loops. It'll disable some interfaces. That way it can prevent basically a loop from happening, which is where the information just keeps basically hitting one switch, and it goes right back to the other switch, and it goes back to the other switch, and the information doesn't get to exactly to its destination basically, because it's all connected to each other. So to avoid that, spanning tree was created. Now this does bring up some issues when we want to basically connect switches together. We still want to have the highest throughput as possible. Now for us to be able to do that without having interfaces basically disabled due to spanning tree, we group these interfaces together in what's called an ether channel. So basically it'll still be the links. So in this case it'll be 4 links physically, but logically or virtually it'll show as one ether channel, and all links will be enabled basically to ensure the maximum throughput. Now this also helps, say one of these links fail for whatever reason, maybe the cable gets damaged. We're still gonna have the other three cables, or three interfaces being able to transmit traffic between these two switches. So now when you use an Ether channel, this allows for up to 8 channels, or 8 interfaces to be grouped into an Ether channel, basically. So now there are 2 different types of protocols. So there's one that's PAgP, which is the Cisco proprietary protocol, which stands for port aggregation protocol. This dynamically negotiates the creation and maintenance of that Ether channel. And then you have the open standard, which is the link aggregation control protocol. So now on that on the test, it's showing that we only have to know the link aggregation control protocol, but we probably should go over both, just so you know a little bit about both, and the terminology used to configure both of them, because they are similar, but there are some key terms that are different. So we'll go ahead and configure. Let's go ahead and jump into switch 1. All right, so, and in this case I'm using layer 3 switches. Layer 3 switches they work the same as a layer 2 switch, where they forward information based on MAC addresses or layer 2 information, but they do have the capability of forwarding or using layer 3 protocols. It's not to say that these will function as a router, but they do have some router capabilities. So let's go ahead and jump into switch 1. We're gonna go ahead and hit enable, and we'll change the host name. This host name is going to be switch 1, so we'll go host SW1. I'm sorry, gotta use the configure terminal, and then we'll do host SW1. And what we want to do is grab the 4 links on this, or the 4 interfaces on this this switch. So to do that, we'll use the interface range. That way we're able to configure all 4 links at the same time. We'll do interface range F01-4. We'll hit enter, and now we are in that interface range configuration. So we're able to configure all of them at the same time. So now, to go ahead and configure that, we'll do channel dash group, and then the number of the group that we want to assign to this port, or this this port channel, basically. So we'll do 1, and the mode that we want it to be in. So now there are 3 different modes that you're able to do. You're able to do a static mode, which does not use LACP nor PAgP. This is what's known as a static mode, but in this case we're going to set it up as an LACP. Now the 2 terms that we use to set up an LACP Etherchannel is active and passive. Now, but You can't use passive and passive, because if they're both passive, they're just waiting basically on an active connection to form that that ether channel. So what you're able to do is, on one side you can use passive, on the other side you can use active, or you can use active and active. Those two will form a basically an ether channel. So on this side we're going to go ahead and use active, and we get the logs showing it's creating port channel interface port channel 1, and then it's basically on the switch. It'll show all of these ports that's showing down, and now they will come. The port channel number does not have to match. It does have to match for each interface within one switch, but on the other side of the other switch, it does not have to match. So you can assign port channel 1 on one side, and you can assign port channel 4, 5, 6, 8, whatever you want on the other side, depending on your on how your network architecture and how you have it set up. But for this lab purposes, we'll go ahead and assign it as the same on both sides. So we'll do channel group channel group 1 mode, and remember, on the other side we used active. On this side we're going to go ahead and use passive, and that will still create a port channel, an LACP port channel. So we'll go ahead and hit enter, and that is showing us here that it is creating a port interface channel. So now what we see here is that all of the interfaces went down here for a brief second. And now it is going through the process of basically creating the port channel. And once it creates the port channel, you see all of the links are up. So now we're not subject to basically spanning tree protocol disabling the links, which is a good thing. Now we have our desired throughput, and we're able to pass traffic between both of the switches basically. So now what we're gonna go ahead and do is we're gonna break down this LACP ether channel, and we're gonna go ahead and create a PGP ether channel. So now we'll do the no channel group 1 mode passive. Does it allow me to do that? No. How do I? I think if I just, okay. So if I think I can just change the mode without breaking it down. So now, like we said, and I didn't explain that part, but for PGP, the two terms that we use to create a PGP Ethernet ether channel, I'm sorry, is going to be auto and desirable. So now, for you to be able to create an ether channel, with PGP, the one side has to be basically desirable. So this is basically the active, and then the other side, at least one side has to be desirable basically. So you can't put auto and auto because it won't form a PGP ether channel. So it has to be either desirable or auto desirable. Okay, so now we'll do mode desirable. No, it doesn't allow me to do that. Let's see if I go into, okay. Okay, it's not letting me do that. Let's do a short run. Okay, so I was able to find how to break down basically the LACP on one side. Let me make sure, do show run. Okay, yeah, so it did remove the ether channel configuration on here. So what I want to go ahead and do is create basically a PAgP ether channel. So to do that, we're gonna do channel. Oh, well, we have to basically group the interfaces together. So we'll do interface range F01 to 4, and then we'll go ahead and use the command channel group 1 mode auto. Okay, so now that's going to create a port channel 1 using PAgP, and we'll verify that by using the do show run. Do show run, and now on the other side we'll go ahead and create the same thing using PAgP. So we'll do config T, group the interfaces together, range and no, actually let me first remove the ether channel. Do show run. Okay, so now we'll do interface range and then we'll do channel group 1 mode desirable. Okay, so now that should create the show interface P01. Alright. I should bring it up. Let me see. Show. Okay. And now it should form. Okay. I couldn't figure out why it wasn't forming the Etherchannel, but I did find that I guess when I negated the port channel on switch 2 or switch 3, I'm sorry, switch 2. It basically it shut down all of the interfaces on here. So now we do have an Etherchannel, so we can verify that. You can go ahead and verify that by using show interface P01, and it says port channel 1 is up, line protocol is up. We can also do a show Etherchannel summary, and we see here that there's a capital S, so that's a layer 2, and then a capital U, which is showing in use. And these are the ports that are aggregated into that one logical link, and the protocol that is being used is PAgP. So now another thing that we are able to do with an Ether channel is basically, so I'm on switch 2. So say we want this basically this link to act as a trunk link. What I can do is go into, so we'll do configure terminal, and we can jump into the Etherchannel and basically create a trunk link. So to do that, we'll do switch port trunk encapsulation dot 1Q, and then switch port mode trunk. Now once I do that, since both sides are not basically the same, one side is using access ports and the other side is using trunk ports, it's showing that it's disabling basically the link aggregation. So if I go back and do let's do a do show Etherchannel summary. No, it's not an okay. This side is showing in use. Let's show this other side. Okay, yeah, that's the area here. So now it's showing me spanning tree, blocking port channel 1 on VLAN 1 because it only has one VLAN. It's blocking the ports due to inconsistent port type, meaning that one side is configured as a trunk and the other side is configured as access ports. So what we need to do is on this switch, we need to go ahead and configure the ports as trunk ports. But before I do that, I wanted to show you that on here, the only thing I did was go into the Etherchannel and configure that as a port. But as a result of that, what happens is that all of the ports that were in the that are in that Etherchannel were also configured as as trunk ports, as I'm going to show you right now. So as you can see here, the port channel is configured as a trunk, but it also all of the interfaces within that Etherchannel are configured as a trunk. Now I did that without having to use the interface range command. All I did was configure the port channel, and it automatically configured the ports, the switch ports, as a trunk. So whatever you do on the top level is going to happen. Is going to happen to the physical ports, basically. Whatever configuration you make on the logical port channel. So now we'll go ahead and do the same on this side, this other switch. We'll go into port P01 or interface P01, and there we'll go ahead and use the switch port trunk encapsulation dot 1Q, and then switch port mode trunk. And now we're gonna get the command showing us that it is unblocking that port channel again, and it says port consistency restored. So now it should show us all of the ports up, and there it goes, and it shows us all the ports up. Now that is basically how you configure and verify basically what ether channels, or basically the commands used to configure the ether channels. Now let's see, what else did that? Okay, so yeah, it's basically configure and verify. That's how you configure and verify the Ether channel. Now the next video I do, we're going to be using, so this was a layer 2 Ether channel. We're going to go over layer 3 Ether channels on these layer 3 switches. So stay tuned for that video coming up shortly. If you like this video, if it was informative, go ahead and hit a like button. I'm going to be uploading this to YouTube, and I'll probably do some smaller clips for my TikTok. If you're watching this on YouTube, go ahead and follow me on TikTok. My username on there is DannyTech1. DannyTech1. You can find me there, and go ahead and hit me with some likes there if you can, and follow if you like. I do some lives. I do like 2 to 3 lives a week on that TikTok, so you can look out for me there. Again, thank you for watching these videos. I really appreciate everybody that watches and takes the time out to lab with me. Again, this is, for me, this is what I consider fun. So again, if you are into networking, I think labbing is probably the most important thing. That way you're able to break and fix virtually without harming your production network, and you're able to learn so much just by labbing some concepts that you're learning or you've learned in the past, and to brush up on your skills basically. So again, go ahead and like and subscribe on my YouTube. If you are watching this on TikTok, go ahead and give me a follow. More videos are to come. Thank you.